Okay. Same with my previous video about integration by parts. Another technique of integration will be discussed, and this is about the powers of sine and cosine. So this is similar to integration by parts, wherein uh, this can be solved using the use of substitution or the change of variable. Now there are 4 cases, so I'm going to discuss cases 1 and 2. Okay. So case 1 is about the integral of sine u du, or integral of sine raised to n u du, or integral of cosine raised to n u du, where n is an odd integer. No, so it could be 1, 3, 5, and so on. Okay. So how are we going to integrate this form? So to illustrate, let's find or let's evaluate the integral of cosine x cubed dx. Okay. Uh, Here's the technique. Uh, you rearrange, you extract one cosine to be part of du. So therefore, our u must be sine x, so that our du will be cosine x dx. So therefore, the remaining part of the integrand will now have an even exponent. Kaya originally odd man. So you extract one and the exponent becomes even. Diba? It could be 2, 4, 6, etc. So convert this one, or replace this one by an expression or a trigonometric identity involving sine. No. So let us have a review of the trigonometric identities. Uh, this is the common one, common form. Cosine squared x plus sine squared x equals 1. So to solve for cosine squared x, transpose sine squared x to the right, like this one. Or for other problems, if you want to get the expression of sine squared x, same lang, transpose cosine squared x to the right, like this one. So for this illustration, we will use one. Cosine squared x equals 1 minus sine squared x, like this one. So after this, expand, distribute ang cosine x dx, and you will have these two terms. Okay. This is a basic formula, basic form, integral of cosine x, basic lang eh. So, derivative technique. So, cosine x dx will be part sa du. Therefore, our u must be sine x. So, let u equal to sine x du cosine x dx. So, na-derivative technique. So, okay. Integral of cosine x dx minus sine x is u squared, and then cosine x dx is du. And this is basic power rule. And the integral of u squared du is u cubed over 3 plus c. And then final step is to replace u by sine x, and we have this. Okay. So the technique is you extract one cosine or one sine to be part of your du. And the result, the remaining part sa integrand will have an even exponent, and you substitute it with a trigonometric identity, and basic na yan. Okay. Another one. Evaluate sine x raised to the 5th power dx. So, add na lang. So, you extract one sine x from the integrand, like this one. And then Replace this one by cosine x so that cosine x will be our u, and then sine x dx will be part of du. Okay. So how to replace sine x raised to 4 with an expression involving cosine? Then uh, simplify. No? Sine x raised to the fourth power is equal to sine squared x quantity squared. Oh, same na sila. And from this one, from trigonometric identities, sine squared x is 1 minus cosine squared x. So you replace and one result, and then expand this perfect square trinomial. This is the result. And then distribute sine x dx. You will have 3 terms. This is the result. So the first term is a basic form. Second and third term, mauna ang u cosine x and du. Of course, derivative of cosine is negative sine x dx. So you're going to substitute this one sa second term and third term. Oh, okay. So these are the terms, and then u and du. Let's substitute. Integral sine x dx minus 2 u squared negative du. Okay? Sine x dx is negative du plus u to the fourth and negative du. So negative times negative becomes positive, positive, negative becomes negative. So integral of sine x is negative cosine x. And integral of u squared du, it's u cubed over 3. And integral of u to the fourth du is u to the fifth power over 5 plus c. And final step is to replace u by cosine x. Okay. So that's the first case, no, where the exponent is odd. So the technique is you extract one cosine or one sine to be part of du. And then the remaining integrand, replace it by an expression involving either sine or cosine. Case 2. Case 2 is in the form integral of sine u raised to n times cosine u raised to m du, where at least one of the exponent is odd. At least, so it could be na both exponents are odd. At least one. So either n is odd or m is odd, or both n and m are odd. Okay. Oh, let's have an illustration. Now, the solution of this case is similar to the method used in case 1, meaning you extract one cosine or one sine, because that is the technique in case 1. So same here. You extract one cosine or one sine. Okay. Illustration. Evaluate the integral of cosine x cubed sine x dx. Now, in this case, both exponents are odd. N is odd 3, while m is odd 1. So, we can use both cases. Na first, to extract sine x to be part of du, or we can extract cosine x to be part of du. Okay. Let's try both method or both solution. So, first one, since basic lang sin x dx, so we can directly assume u equal to cosine x. So, du is negative sine x dx. So, therefore, sin x dx equals negative du. Uh, so, the result is this, integral of u cubed and negative du. So, integral of negative integral of u cubed du. The answer is this, and replace u by cosine x. Uh, it's very easy, since m is just equal to 1. Okay. Now, the second one is cosine x will be extracted to be part of du. Para ma-part siya sa du. So, this is what will happen. Cosine x dx and cosine squared and then sine x. So that cosine x, so that our du will have cosine x dx, our u must be sine x. Para ang du, cosine x dx, sine x. So we have cosine squared x, even, because originally, add man siya, and then di-extract ang cosine x. So, the exponent becomes even. So we will replace this one by the trigonometric identity, like this one. And then we distribute. Okay. So you can use the use substitution here. Basic na lang man. Let u equal to sine x for both terms, and du is cosine x. So I like this one. Integral of u du minus integral of u cubed du. So the next step is integrate na. We have 1/2 u squared, or u squared over 2, u to the 4th over 4. And then replace u by sine x. Okay. Now, if you will notice, for this one, your answer contains sine x, while the previous one, it's cosine x. Okay. So how come they are not the same? Now, if you will simplify this one, you'll find out na they are similar. Okay. Oh, uh, you can try it for yourself and prove that this negative 1/4 cosine x raised to 4 plus c is equal to this. It's for you to prove. Okay. But this can be proved. This can be one. I mean, you can prove this one, that this is equal to the previous one. So that's it for cases 1 and 2. Thank you for watching.